Okay, we're doing the 2-5 notes. An inverse. Now we can think of inverses like what is the opposite of adding, subtracting? What is the opposite of multiplying, dividing? Make sure you're all getting ready to take notes because I'm getting a strange feeling that's not always happening. Yeah, I hope so. Get a broader definition of something that's not just a single operation like multiplication, division, adding, subtracting, squaring. What's opposite of squaring? Square root, okay? But if we want to be able to get a broader definition, because what if we have multiple operations together, not just a single operation, we need a strategy for how to find an inverse, okay? So step number 1, define an inverse. If any of you have worked on cars or anything mechanical, you understand the idea of operations that are inverses, because you have to take something off in order to reinstall something that actually works. An inverse is simply a matter of switching x and y. That is a really simple definition right there. And in the example that we're going to work on first, that is literally all you're going to do. But in several of the other examples, there will be a second step, and it will be to solve for y. Now, hopefully you have that written down somewhere so we can move down to question 3. That's where I want to start with, because I think that's the easiest question. Switch x and y's rule number 1, which is all we're going to be doing for this first example. Now, in question 3, they said that the original points are in blue. Now, if you're dealing with a paper copy right now, you have black and white stuff, and it doesn't make any sense. But these are the blue ones. Okay? Then it says that the inverse is in red. The inverse is in red. Okay? So what I want you to do is think about and look for answer choices down here that have the x's and y's switched. That's it. So all they have is the x's and y's completely reversed. Is it A, B, or C? Which table has them switched? A, B, and C. It is choice A. These are the red ones. For those of you who are working off of printed notes, you might want to look at mine for the red and the blue. But you need to choose a graph now which has the blue points and the red points in the correct locations. So use those two tables and find a graph out of A, B, C, and D that has that situation. Okay, which one is correct? Oh, B. Yes, that's true. It is choice B. Now, I want to zoom in and take a look at choice B. And show you something. There's a line that I'm drawing right now. I need you to tell me the equation of this line. Instead of just doing your own thing, come on, tell me the equation of that line. Think about the slope. Think about the y-intercept. We know every line is y equals mx plus b. What is this specific line? Y equals x, thank you very much. It's got a slope of 1 and a y-intercept of 0. What do you notice about that line in relationship to the blue and the red points? It splits it like an axis of symmetry, right? It's symmetric across that. Please make sure you're writing things down. Okay, so we've got this line, and we say that the inverse is reflected across y equals x. The inverse is reflected across y equals x. Did that happen for letter A? If I draw that line in there, is it a complete reflection on letter A? Actually, that is a translation left and down. You're right. Okay. Letter C. Do you see that reflection happening there? What is it? Yeah, wrong axis. They are reflecting across the line x equals 0, or the y-axis. Nicely done. Is this reflection happening here? No, it's not. Not across that line. Which line is it reflecting across? The x-axis, thank you very much. What? Right through there? It is pretty close, but I think you're right. There's a, you know what? It's not quite the y-axis. It's a little bit below that. Or the x-axis. It is just a little bit below that, because you're right. The distance from here to here and the distance from here to here aren't the same. First two on the left, or the first two? So there's 3 units right there. There's 3 units right there. That's 2 units. That's 2 units. This is 6 units, and this is 6 units. The only one that I would really question would have been that pair right there, because it looked like 1 and 2. I'm not sure. You can talk to me later about that one. But it's definitely not a reflection across y equals x. Okay, somewhere in your notes, do me a favor and draw yourself a picture of a parabola. Just a generic looking parabola. And I'm going to do my best job to come up with the line y equals x, like that. I want you to practice. You can use a different color. You can use a dotted shape. But I want you to try to draw the inverse, knowing that it has to be a reflection across that line. Try your best to draw what you think the inverse is going to look like. You did, okay, that's not a reflection across that line. You did a reflection across the x-axis. So we want a reflection across that line. That
Oh, so yours was 3 years ago? Oh, what's yours? October 14th. October 16th. October 17th.
Ladies and gentlemen, you see the picture on the parabola that I have drawn. Look up here. Yes. Alright, so you see the picture? See the line that I've drawn? The line y equals x. Okay, now watch, because this is a reflection, folks. Okay, so here's a reflection. Okay, I told it right along that line. Now I want you to look through the back of the piece of paper to see the vetting that I drew. Which way is it facing now? It's facing to the right. Do you see that? Do you see that it's facing to the right? Because that's the reflection that we should have drawn. We should have had this open thing to the right. That's the shape that you guys, some of you came up with. Some of you came up with that idea. We have our reflection, and now it's opening to the right. Okay, you guys see what's going on here? Okay, now, so the part under the blue line came above it, and the part above the blue line came below it. The part over here, this chunk over here, ended up doing this. Now, the purple graph, is it a function? How do you know it's not a function? It fails the vertical line test. Right? Fails the VLT. Yep. Not every function's inverse will be a function. So we took this and made it into this. See that? That reflection? This became this. Folks, this did not become, it did not do this. That's a rotation. That is not what we're talking about here. This part reflected this way. This part came down here. Okay, now, back up to question 1. If we're dealing with, okay, now, what kind of graph is this, by the way? Anybody know what y equals 5x minus 9 looks like? It's a straight line. What's the y-intercept? -9. What's the slope? 5. So the original graph looks something like this. Fairly steep, goes through the y-intercept at -9. Okay, now if you're thinking about this in terms of reflection, we know that it's going to reflect across that line. What's going to happen with the point that's sitting right here, the blue dot? What's going to happen to that point when we reflect it? When we do the reflection, what's going to happen to that blue dot? It's not going to go anywhere. Good point. That one's going to stay put. You should be thinking about a shape that looks like this. Now we're going to find the actual equation of that line. First thing we do is switch x and y. So we've got x equals 5y minus 9. That's step number 1. Step number 2, solve for y. So what do you do to solve for y? What are we going to do with the 9? Add it, right? X plus 9 equals 5y, and then of course, as you said, divide by 5. Is this a good answer? Besides the fact that my 5 and my 9 look horrible. That is a good answer. Is this the same answer? Is that the same answer? It is exactly the same answer. It has a y-intercept of 9 over 5, which is 1.8, just a little bit lower than 2, and it's got a slope of 1/5. That's the orange line that we drew. It's hard to tell. It's slightly different. It's easier to tell on my screen than it is on the big screen. Okay? Yeah, okay. I heard you. I tried to do a different color this time. We will practice more tomorrow, but I do want to ask this question. Is the orange one a function? That's a big yes, right? Passes the vertical line test. And we will complete these notes tomorrow.